On July 20th, 1969, the world watched in awe as humans first set foot on the moon. The Apollo 11 mission with astronauts Neil Armstrong, Buzz Aldrin and Michael Collins captured the imagination of people worldwide. It showed that we could overcome seemingly insurmountable challenges and achieve the extraordinary. The moon landing became a symbol of human potential and inspired generations to dream big. The impact of this event extended far beyond the realm of space exploration. The technologies developed for the Apollo program, from rocket propulsion to communication systems, have had lasting impacts on various fields. Moreover, the moon landing fostered a sense of global unity. People from all walks of life, regardless of nationality or background, shared in the excitement and wonder of this momentous occasion. It reminded us that we are all part of one human race, capable of achieving greatness together. The dream of reaching the moon is not new. For centuries, humans have gazed up at the night sky and wondered about our celestial neighbor. Early astronomers made detailed observations, mapping the lunar surface and studying its phases. In the 20th century, the dream of space travel began to transition from science fiction to reality. Pioneers like Konstantin Tsiolkovsky and Robert Goddard laid the groundwork for rocketry. The space race between the United States and the Soviet Union in the 1950s and 1960s accelerated progress toward the moon. The Soviet Union achieved early successes, launching the first satellite, Sputnik, in 1957, and sending the first human, Yuri Gagarin, into orbit in 1961. These achievements spurred the United States to intensify its efforts, culminating in President John F. Kennedy's bold challenge to land a man on the moon and return him safely to Earth before the end of the decade. Landing on the moon presented an unprecedented engineering challenge. One of the most significant challenges was designing and building a rocket powerful enough to escape Earth's gravity and propel a spacecraft to the moon. The Saturn V rocket, developed by Wernher von Braun and his team at NASA, was a marvel of engineering. Standing over 360 feet tall and generating 7.5 million pounds of thrust, it remains the most powerful rocket ever built. Another critical challenge was designing and building the lunar module, the spacecraft that would land on the moon. The lunar module had to be lightweight yet strong enough to withstand the harsh conditions of space and the lunar surface. Communication was another significant hurdle. Engineers had to develop reliable communication systems to maintain contact between the astronauts on the moon and mission control in Houston. Section 4: The Right Stuff Astronauts and the Final Frontier. The astronauts who embarked on the journey to the moon were not just skilled pilots and engineers, they were pioneers, explorers, and heroes. Selected from among the best and brightest, they underwent rigorous physical and mental training to prepare for the challenges of spaceflight. Astronaut training included simulations of spacewalks, docking maneuvers, and lunar landings. They spent countless hours in centrifuges, replicating the intense G-forces experienced during launch and re-entry. Beyond the physical challenges, astronauts also had to cope with the psychological demands of space travel. The success of the mission depended not only on their technical skills, but also on their ability to remain calm and focused under extreme pressure. Section 5: The Future of Lunar Exploration. The Apollo missions marked the beginning, not the end, of our journey to the moon. After a hiatus of several decades, there is renewed interest in lunar exploration, driven by scientific curiosity, technological advancements, and the potential for economic development. Space agencies and private companies are developing plans for future missions to the moon. These missions aim to establish a sustained human presence on the lunar surface, conduct scientific research, and explore the moon's resources. One of the key goals of future lunar missions is to search for water ice, which is believed to exist in permanently shadowed craters at the moon's poles. Water ice could be used to support human life, generate rocket fuel, and unlock the moon's potential as a stepping stone for further exploration of our solar system. Section 6: A Giant Leap for Humanity. The journey to the moon has been a testament to human ingenuity, perseverance, and our innate desire to explore the unknown. From the early dreams of reaching for the stars to the technological marvels that enabled us to land on the lunar surface, it has been a journey filled with challenges and triumphs. The moon landing was not just about planting a flag on a celestial body, it was about expanding our horizons, pushing the boundaries of human potential, and inspiring generations to come. The lessons learned and technologies developed during the Apollo program have had a lasting impact on our world, advancing science, technology, and our understanding of our place in the cosmos. The moon landing was a giant leap for humanity, and it is up to us to continue the journey.